Okay, next to last, we're going to talk a little bit about design of experiments, or DOE. This is one everybody associates with Six Sigma. Honestly, I don't use it that much because part of it is you just induce variation, and I've generally found that there's enough variation within the process already. I don't need to make any more, but we're going to talk about it. Here we go. Now, traditionally, when you do an experiment, what you do is what's called a one factor at a time. You basically just take one factor and you change it and see what happens to the output, right? The trouble is, sometimes you do that, you get what's called interactions, and these interactions will react with the other bits of the process and change, right? So what design of experiments does is basically not trying to get the one factor right, but trying to get the mix right, everything together. So what you do is you not only measure the one factor, but also the interactions. And the inferential space you get is much greater than if you did one factor at a time. Now in my live classes, what I'll do is I'll do about 4 hours on design of experiments. And I actually do a little experiment. It involves dissolving aspirin and things. I can't really do that over this video or over this PowerPoint. But take a look at the readings. I put some videos that'll tell you about it. If you have a black belt or green belt, or anybody familiar with design of experiments, ask them about it. But some of the advantages is that you do simultaneously evaluate several factors in a process. And by insensitive to noise, you can make this so that noise is spread out. And you can focus in on the true factors. The statistics are very easy on this one. Few experiments. If you don't get the results you expect, you can say, oh, there's something else going on. And especially with computers, it's easy and it's cheaper, right? Get a lot of information for just a few experiments. Like all things, DOE has its own language. I've listed some here. And what you want to do is, instead of me going over it, pause it now and go look up each one of these terms in terms of DOE. Just put in DOE factor and see what comes up. Okay. Now this actually, the way I teach it with the orthogonal arrays, came about in the late 1950s, but this has been around for a while. In fact, it was originally developed by the Department of Agriculture in the United States. So what they do is they look at the different combinations. Let's go back to originally what it said. They knew that you had to have rain, light, temperature, all played a role in crops. So what they did is they varied those three and found the right combination. And that's how you basically get the green revolution that we had started. Just what goes into making a good crop. But we're only going to talk about full DOE here. First thing you have to do is figure out what factors are important. And where does this come up from? Well, you can do a brainstorming, look at your FEMA's capabilities, measurement system analysis, other DOEs. Wherever you get from, you put those factors, okay, this will have an influence on my outcome, and you do the experiment. Okay, how many experiments do you have to do? Well, there's two things that go into the number of experiments. There's the levels. I'm going to use basically cooking, making cinnamon rolls. You got a lot of cinnamon, a little bit of cinnamon, a lot of brown sugar, a little brown sugar. You got whole wheat flour. You got regular flour. 2 levels, everything. And again, we got 3 factors I'm going to change: the sugar, the cinnamon, and also the flour type. Well, the way you figure out how many runs you have to have, you take the levels. In this case, it's 2. Number of factors. This time is 3. So there's 2 to the 3rd power. 2 times 2 is 4 times 2 is 8. So you're going to need 8 experiments to figure out cinnamon rolls. Another example, you got a 4-factor experiment, 16. It doubles with every factor you've added. I put this slide in here because I want to show what you're able to do. What you're able to do is do an inferential space, and it's in 3 dimensions. In this case, they got 3 factors. And whoever Jason Rim did this experiment, and he was able to figure out what happens within that space, right? So you can pick a spot anywhere in that space, adjust the temperature, time, and contact angle, and tell you what's going to happen on the output. So after you've made all these changes, right, and you got this little improvement after one run, you don't stop there because it can be done even better and better and better. Think about television, electronics. You know, every 2 weeks when I was growing up as a kid, we always had something going wrong with our TV. Now it's, man, I can go 20 years with one TV, or cars, anything. It's all about getting better and better and better. So what you do is you DOE, and then if you want to say, I want to get better, you might try some other factors, try a little bit different levels about where the optimum is, and see if you can fine tune this thing and just keep on getting better and better and better. And again, we're talking about a process, but it could also service industry. Well, how is it if I have the customer input their own order versus somebody doing it over the phone? Or how about if I had a good one is, I ate at a restaurant. You can pay the bill electronically, swipe the card and all that without ever seeing the waitress. It's very slick. I mean, it's getting better and better and better. Service, products, everything can improve with DOE. Okay, in the discussion, I'm going to attach a spreadsheet. I've already done it once, but I'm going to send you another one. This is the DOE spreadsheet. And what I'm focused here in the red box, that's the factors. And if you can see this, if you blow it up a bit, you can see that the primary, that factor A is important. But the next important is actually how factor A interacts with factor B, right? And so it tells you that if you change A, you also got to be careful of B, even though if you look at B, it doesn't have that much impact. So this is what they call by interaction, and this is where you try to get that recipe exactly right. And this is where I'm going to leave it on this PowerPoint, but if you have any questions, give me a call.